Hi, I figured we'd use this as an opportunity to go over some probability problems. What I'm going to do is I'm going to show you how to solve this problem specifically using a Venn diagram, and I'll put up another video showing you how you can use a table. People like to go either way with this, so I like to provide both options. So I'll give you a chance to see how both would work. So I'm going to look at this problem right here where it talks about 56% of all Americans have a workplace retirement plan, 68 have health insurance, and 49% have both benefits. So what I want to do is I'm going to start out by doing a Venn diagram for this problem. Again, we could do tables too. I'm going to do tables in another video. So if you want to see what a table might look like, that's cool. I'm going to go with the Venn diagram here. Let's see how this rectangle comes out. Hey, not bad. All right, so I'm going to go with two circles. So I'm looking at two situations here. I have retirement plan and health insurance, and they also have both benefits. So I'm going to plug in what I know. Now it's telling me 56% of people have workplace retirement plan. So when they're telling me that, that means this whole circle here, that whole R circle, that's going to be 56. When they're telling me 68 have health insurance, that means this whole circle that I just colored in is going to add up to 68. Chances are you notice I colored something in the middle, that overlap. So what you want to bear in mind is that there's going to be overlap between that 56% of American workers who have retirement and 68 who have health insurance. Now, the last part they tell me is that 49% have both. That makes it nice and easy because I know that the both is going to be right here, that overlap right in the middle. So what can I do with this now? Now, if you remember that retirement plan, right? We said that that was going to be 56% of all workers. Now, this whole circle here, notice how I'm kind of highlighting this whole circle. This has to add up to 56. I've already accounted for 49 because they have both. So that means I'm going to take 49 away from my 56. And that's going to leave me with my 7% who only have a retirement plan. And you'll notice that there's no overlap here. They're just in that retirement part of the circle. And we have the 49 who are in both. So that encompasses the whole 56% that have retirement. Now, for health insurance, I believe it was 68. Let me double check. It is. So I've already accounted for 49% of this circle. So what I'm going to do is I'm going to take 49 away from 68. And that's going to leave me with 19. What that leaves me with is the 19% who only have health insurance. So I've accounted for the 68% in my health circle and the 56% in my retirement circle. What this allows me to do now, since I know I'm working with percentages, which is very handy, I can add up everything in here. I can add up my 49, my 7, and my 19. And if I add them up, I should probably have done this with the calculator, but that's all right. I'm going to get 75, which means that 25% are going to lie on the outside here. They don't have anything. So I'm just going to leave them there. All right. So now this gives me the opportunity to answer some questions. So the first one asked me, has either employee-sponsored health insurance or a retirement plan? Now, this is a good opportunity to use our general addition rule, where you have probability of A plus the probability of B minus the probability of them happening both at the same time, because what we're doing is we're getting rid of that 2 that we've already counted, should give you the probability of A or B. So let's plug in what we want here. So we'll use A. Our A event will be the probability of having health insurance, which is 56. Remember, I'm going with specifically everything in that circle, not just the people who have only retirement. I'm going with everyone who has retirement. I think I might have said health insurance, but I'm going with retirement. Now for health insurance, I'll make that B. I'm going to add up everybody in there, which is that 68. Now probability of A and B, I'm going to take away that 49 right there because that's getting counted twice. When I count that 56, that includes that 49. When I add that 68, that also includes the 49. So there you go. That's where this is all coming from. I'll do this out of 100. I can do decimals. I can do fractions. Why not? Why not do some fractions? So then if I just do this out, right, I'm adding the probability of A plus probability of B minus the probability of them both happening at the same time. I'm going to get 26 out of 100, which, believe it or not, the easy way of, ouch, I shouldn't be getting 76. That's my bad. I should be getting 75, excuse me. I made a cardinal mistake there, and I hope you saw that. What I do is I only added initially those who only had retirement or only had health insurance. I didn't include the both there. I do have to include the both. The thing is, I just have to remember I'm not using it twice. Awesome. So that answer would be 75 out of 100 or 75%. Now, part B says he has health insurance if he has a retirement plan. So here's what I want to approach it as. Health insurance given they have retirement. So I'm looking at only this retirement circle. My given is going to be the retirement circle, which is 56. Out of that 56, how many have health insurance? That ends up being 49. 49 out of that 56. Which I can simplify if I want to, the 7 out of 8. Good. So now, chance on my next question are, it says, are having health insurance and a retirement plan independent events? Here's what we want to remember about independent events. A lot of times we try to go just based on logic. You have to prove an independent event mathematically. Now, ultimately, what that means is that there's no relationship between one event and the other. So what we're going to do is we're going to try and prove that. So there are a couple of ways I can do it. I can do a probability of A times the probability of B to give me the probability of them both happening at the same time. Let's see if that happens here. Probability of having a retirement, 0.56. Probability of having health insurance, 0.68. If these are independent, I should get that probability of 49% in the middle, the probability of both. I'm inclined to think that's not going to work. I'm telling you, just looking at the numbers, 0.56 times 0.68 probably won't give me that. Let's see, though. Now I might pull up my calculator. There we go. 0.56 times 0.68. 0.3808. That's definitely not 49%. So I can say that these events aren't independent. There's some sort of relationship going on there. Maybe if you have one, you're more likely to have the other. Who knows? But it's not independent. It's not consistent. That having health insurance, that probability changes once you have retirement plan. There's another way I can prove this. I can also do what we just did here, actually, the probability of having health insurance given I have retirement. If I look at the probability of having health insurance, that's 68%. Now, if these are independent events, what I should be noticing is that the probability of having health insurance given I have retirement shouldn't change. If it's independent, it should still be 68%, regardless of whether you have a retirement plan or not. So let's see, I did 7 out of 8. I'm just going to double check it on the calculator. I should probably know this, but 0.875. So it tells me is if I have a retirement plan, I'm more likely to have health insurance. So I've just proven that these events aren't independent. Cool. So this is an example of how you can use a Venn diagram to answer questions like this, as well as answer questions of independence. I'm going to do another video as well, so you can get a chance to see how it is done using tables. Hopefully this helps.